Here are some lessons learned from FutureGrid. One important lesson was that we've already mentioned. Uh, we did not expect such a large use from computer science and middleware. We expected more application use. In retrospect, it's rather clear why we have had more from computer science and middleware, because some of the application users are only really interested on testing on large systems because that's what they want to do. And you cannot on FutureGrid test the scaling of your application to huge environments because we only have 4,700 cores, and those cores are very heterogeneous, scattered across the country, and you can't use all of them within any one experiment. The largest single cluster has 1,024 cores. Another important lesson is the rapid evolution of the technology. We started off intending to use eucalyptus. We soon switched to using and developing Nimbus, and now we're moving to OpenStack as the most popular environment we have. We can see this evolving of the technology from the headlines. One recently, PayPal dropped VMware from 80,000 servers and replaces it with OpenStack. The corresponding headline says VMware loses $2 billion in market cap as eBay expects to take this PayPal switch and expand it to their entire environments. Of course, eBay has lots of internal expertise in running systems, and what they can do may not be doable by most of the industry users of computers. So I think this does not say that commercial virtual machine managers like VMware producers are no longer interesting. It just says that if you have a very experienced staff, you can consider using now the open source approaches, because they're now robust enough to be usable, but they still require, of course, a lot of work. Another important lesson from FutureGrid is that we need interactive use, not batch use, and also that nearly all our jobs are short. So that says, actually, we're not limited so much by the hardware, although we are limited in some sense by the hardware because we can't actually do some things. We can't do large tests. If you want to test MapReduce on 1,000 nodes, you can't do it on FutureGrid. But most people are not doing that. They're using small number of nodes, and they're doing it interactively, so they're not using a lot of time, but they are using a lot of support, because the support tends to scale with the number of users, not the number of nodes. We had to develop quite a bit of testbed as a service technology, and we also had to develop the operational model to support this type of environment. I think in general, FutureGrid, the lessons are positive. Namely, we had a lot of successes, and clouds are very successful. And that's a little different from the Magellan project from the Department of Energy, which was aimed as a science cloud and pointed out some of the difficulties. So FutureGrid really had a different goal from Magellan. You can even say the low application use of FutureGrid reflects the slightly negative tone Magellan had for the current cloud, open source clouds, and supporting science. I mean, there are in fact still serious performance problems in clouds for networking and devices like GPUs. So your InfiniBand card and your GPU card do not run as fast as you would hope on clouds. But those issues, I think, actually will be fixed because there are many activities trying to address this. And you can, in fact, get good InfiniBand performance, for example, on a peculiar combination of operating systems and Mellanox drivers. But the trouble is, those aren't the operating system that we want to use. So basically, there is no good deployable way of getting good performance in a broad fashion at the moment. Our experience of running FutureGrid has allowed us to identify characteristics of optimal hardware, which we'll be happy to share with you if you're interested. An important aspect of the way FutureGrid is managed is this is not a system where you can have sort of separate silos, a user silo, a software silo, and a systems administration silo. You really have to integrate all those together, because this is all flaky, evolving software and flaky, evolving functionality. And to get all of that right, you need to run an integrated environment. And finally, we suggest that we've identified computer testbed as a service as a field. We try to build a community in that area and expect to build it more in the future. So this slide here tells us some futures that we've identified. We actually are ready to support more users than we have in the past because the technology like OpenStack has matured. We do need to improve our hardware to do this because our hardware is now getting a little old. And as I've said, it is somewhat limited in some of the things it can do because of the number of cores we can use on a single environment. I expect to see more interest in platform as a service. For instance, the social networking scientists looking at HBase and MongoDB, they needed substantial help in order to get those systems working because those have a lot of computer science expertise needed to make them function properly. We also expect as the general research area evolves that we will have many big data challenges coming along. We are working very hard with education and training, and this MOOC is one example of that because we're trying to build a set of MOOCs so that we can have pre-recorded a set of training material for FutureGrid. So if you want to use FutureGrid for something, you can, and you may even make yourself a MOOC which uses FutureGrid. The part which is the training on actually using FutureGrid, you can take from us and just incorporate those video segments into your MOOC. We need to finish, or nothing is ever finished in these technology fields, but we need to declare a success point for Cloud Mesh and RAIN and integrate it hopefully with technologies like Horizon from OpenStack and Phantom from Nimbus. And this will allow us to have this usage we discussed a little earlier, where FutureGrid is a hub to jump to different production clouds. And this comes back to allowing something called cloud bursting, where we want to better support people who develop their programs on FutureGrid, and then when they go to production, they can either start a little core on FutureGrid and automatically burst to Amazon or some large science clouds as we expect it to be deployed in the near future. We see a lot of interesting work to be done with Genie, moving more to software-defined systems, and also with high-performance virtualized devices, such as the Intel mic and GPU environments from NVIDIA and others. Monitoring has to be improved because if you're running a test bed, you better have monitoring. And as well as the monitoring, we need to continue our work on experiment management because we want to support reproducible experiment management environments. And as I said, or at the top of the slide, we need to work on ways of expanding and renewing the hardware, possibly by federating with the other existing hardware and working with other collaborators. Thank you very much. This is the end of this discussion of FutureGrid, and I hope you find FutureGrid useful for you. And there is another presentation which gives more details on some of these topics. That's also available in the same MOOC repository. And thank you.